large intestine, I mean, I don't really, I'm going to show stuff on myself because physiologically, large intestine is kind of boring. No, seriously, somewhat. So, large intestine. Hold on a second. So check this out. So this is, large intestine, right? It starts here. This pouch is called cecum. And cecum is separated from small intestine by ileocecal valve. So you go duodenum, like duodenum, jejunum, ileum, then you have a valve, which is sphincter basically. Does that make sense? And then you have cecum. So what's the importance of cecum? Most of the human intestinal microbes are there. I could talk for probably 4, 5, 6 hours about the importance of microbiome, human microbiome. I can tell you this. One of my favorite stories, unfortunately I don't have those pictures. My wife sent them to me some time ago. She works used to work with germ-free mice that don't have any microorganisms in the digestive system. So they poop doesn't have smell, and mice themselves don't smell. But what's interesting, she sent me pictures of the cecum in a regular mouse, conventional lab mouse, and a cecum in the mouse that doesn't have intestinal microbiome. We're looking you look at the regular mouse cecum, it's small, yeah. In germ-free mice, it's so big that when she started to work with them, and she saw male germ-free mice, she was shocked and said, "It can't be. Male mice can't be pregnant." Well, they aren't pregnant. The abdomen is so swollen from ginormous cecum. So there are anatomical abnormalities in the development because they don't have, proper bacteria. That makes sense? Of the cecum, well, for some reason it's lost here. There should be appendix. Oh yeah, here it is, the vermiform appendix. Appendicitis is, inflammation of this. And then you go cecum, then you go ascending colon, transverse colon, descending colon, sigmoid colon, and not here but rectum. And at the end of the rectum is anus. Does that make sense? What is the function of large intestine? Look, I'm not even drawing anything. What is the function of large intestine? Sucking the last traces of water and compacting the feces. Your fecal matter, in the normal scenario, during the day, you lose about 100 mL of water, which is very small amount. Does that make sense? Structural features. You see this kind of pocket-like structures here. That the colon, large intestine, basically has those pockets, individual pockets. They're called haustrum. Each pocket is the haustrum. Their function is to compact the feces. Does that make sense? You see this white line? It represents a long, smooth muscle called tinea coli. Tinea means worm. It's not a worm. So like colonic worm. Or colonic, no, it's not a, no, tinea is a tape, colonic tape. What happens? You're probably familiar, you don't have to change your facial expressions, but after a meal, an ordinary human often has an urge to defecate. It's pretty common. Why does it happen? Well, if you think about it, it makes perfect sense because you eat something, so your stomach dumps its content further into the small intestine. small intestine opens the ileocecal valve and dumps its content into the cecum. Does that make sense? And whatever you have in colon, you have to get rid of it to make some space. Taenia coli produces what we call a mass movement, a very, very powerful contraction which basically pushes the feces towards the anal orifice. That make sense? Clear? This is why we have often go, number 2 after we had a meal. That's absolutely physiologically normal. Now, since we are at we reached the anus. So the anus, you have a couple of structures, anatomical structures, I list them in the study guide, which are anal column and anal sinuses. Those are structures that produce mucus. Why would you need mucus at the point of anal orifice? Lubrication, yes. So epithelium changes from columnar to stratified squamous because a lot of, rubbing. That makes sense? And what happens? So, feces in the rectum, okay, result in a stretch of the rectum. So that stretch internal anal sphincter relaxes. Okay? Does that make sense? Now, talking about a pretty unpleasant part of human physiology, but as adults, we usually, we are aware about the urge to defecate, but we don't usually follow that urge right away, right? We can hold it for a while. Why can we hold it? Because we are aware, CNS, our cortex knows, hey, dude, you gotta go poop, okay? So what happens, you have an external sphincter. You have internal anal sphincter, and you have external. Internal anal sphincter is out of your control. Once the rectum is stretched, it relaxes. We're good to go, okay? And the last checkpoint is your external anal sphincter, which relaxes when you say it relaxes, so to say, And then that's defecation. Does that make sense? Of course, there are limits. It's tug of war, so you can hold only for so long, obviously. But that's the regulation. So internal is involuntary, external is voluntary. Does that make sense? Last activity, that basically concludes the digestive system in its entirety. Last activity that I wanted to mention is vomiting, which is kind of fascinating. So you have 3 types, well, you have 2 types of vomiting. You can have gastric problems, right? You have some kind of irritation in the stomach, or it's overstretched, or there's the pyloric valve is blocked, right? You follow me? So that causes acidic vomiting. It's garden variety vomiting when somebody gets drunk, right? Get drunk. Well, it's a little bit more complex. Let's not get into the drunk part. It's slightly different. That's mostly because of motion sickness, drunk. So you get, you eat something bad, right? And your stomach sends the signal to the medulla, hey, dude, we have a problem here, okay? And there's a vomiting center in medulla which will produce chemicals that will initiate reverse peristalsis. Does that make sense? So your digestive system will start pumping stuff up. That's acidic vomitus. If you go, and yeah, just like during eating, the larynx is closed by epiglottis, and the nasopharynx is closed by uvula. It's not really good closure, so if you ever vomited, you know that vomitus will get into the nasal cavity no matter what. Uvula is not working terribly well. So plug. And then there's basic vomiting. This happens when you have occlusion somewhere in the intestine. Does that make sense? It's much more violent because you gotta have like a stronger push, and it will contain bile, for example. Does that make sense? Yeah, that's it. Any questions?